Hello, welcome back to Math Vibes Tutoring, where we'll be talking about solving equations with variables on both sides. This probably will be in one of your pre-algebra courses. This is not really an Algebra 1 concept. You will see it in Algebra 1, but in terms of it being introduced, that will be in a pre-algebra course around probably 7th or 8th grade. Okay, so we are solving equations with variables on both sides. So up until now, you've solved one-step equations and two-step equations, but you've not solved equations with x and y's and c's and d's and all of those things on both sides of the equal sign. So we're going to do some examples of this, and I'm going to show you exactly what to do. Okay, so let's look at the first example. I have 3x plus 2 equals 5x. Okay, so our goal into this problem is to get the variables to be on one side of the equal sign. Okay, it really does not matter which side you want your variables to be on versus which side you want your numbers to be on. I tell my students to choose the easiest side. Okay, some teachers say all letters go to the left hand side, meaning all the variables should be on the left hand side. It really doesn't matter. Okay, it really depends on which side. Moving it using the inverse operation makes it easier. Okay, so I am going to choose for this one, I am going to choose, since I already have this 5x over here by itself with no other constants, I'm going to choose to move my 3x over to this side right here. Okay? I'm going to choose to move this 3x over to this side because all I have here is 3x plus 2. They're not like terms, so I can't do anything now. So I am choosing to move this entire term, not just the x, not just the 3, but the entire term to the other side by using an inverse operation. Okay? So if I am looking at this 3x, let's think about this as a positive 3x. The only way for me to get this to move to the other side by canceling is to use an inverse operation. So I am subtracting 3x from both sides. Okay, because at this moment right now, I'm not trying to solve for the x. I am literally trying to take this entire term and move it to this side. Anytime we move terms across the equal sign, it has to be done in terms of an inverse operation. So when I subtract 3x here, that's the only way that that's going to get that to cancel out. Okay, so now what I actually have on the left hand side is 2. I have my equal sign, and then now I have the 5x minus the 3x, and that gives me 2x. Okay, so now we have a one-step equation. So again, it doesn't matter if your variables will be on the left-hand side or the right-hand side. We're going to do these the exact same way. So now I have 2 equals 2x. At this moment, I am ready to solve for x. However, the 2 is right here. Okay, so now I'm not trying to move the entire 2 back over here. I am literally trying to get rid of the 2 in order to solve for x. So I see that 2 and x are being multiplied. So I'm going to use an inverse operation of division. Okay, and so what we do on one side of the equation, I must do to the other side. So 2 divided by 2, it cancels itself out. It gives us 1. It's a different color. Let's do this. Okay, so x right here, and then 2 divided by 2 right here is 1. So x is equal to 1. So if that wigs you out, if you want to see x equals 1 this way, that's fine as well. Okay, now we can always go behind ourselves and check. So if x is equal to 1, I'm going to put down here, we're going to check it. Okay, if x is equal to 1, so now every time I see an x, I'm going to plug a 1 in to the original equation. So 3 times 1 plus 2 is equal to 5 times 1. So 3 times 1 is 3, plus 2 is equal to 5 times 1. 5 times 1 is 5. 3 plus 2 is 5. Does 5 equal 5? Yep, it does. Okay, so we know that x equals 1 is our solution for this particular equation. Okay, let's move on to the next equation right here. We have 2 minus 3b equals 7b plus 12. 2 minus 3b equals 7b plus 12. So the first thing I'm going to check for is any like terms. Okay, so I have no like terms on the left-hand side. I have no like terms on the right-hand side. Remember that equal signs serves as a stop sign. Okay, so the only way we can start moving stuff across the equal sign is if we're doing the inverse operations. So what we're going to do at this moment is decide which side we want our variables to be on. Okay, it doesn't matter which side you want your variables to be on at all. Okay, since I moved my variables to the right for the last one, I'm going to move my variables to the left for this one. Okay, but I could move my variables to the right. It doesn't matter. So I am going to choose to take this 7b, and since I know it is a positive 7b, I'm going to choose to move it to the left across this equal sign. So when I am choosing to move this 7b across the equal sign, I am subtracting 7b. Okay? Why am I subtracting 7b? Because I know that that's the only way that that is going to cancel. Okay? So that 7b right here and this negative 7b, you see they're canceling. There's no more 7b on that right-hand side. It's now moved to the left-hand side. So what we have now is 2 minus. Okay, let's check out these terms. All right, so we're looking at this part right here. So negative 3b minus 7b. Or you can think about it as negative 3b plus negative 7b. Or we can think about it as just combining negative 3b and a negative 7b. That's just your integer rules, all right? And that's going to give us 10b. We still have our equal sign, okay? And on the right-hand side, we have this positive 12. Okay, so right now we have moved our variables to the left-hand side. So we have 2 minus 10b equals 12. At this moment, now that I have my variables on the left-hand side, this 2 needs to go to the other side with the 12. You see this 2 does not have a variable, so that means it needs to go across the equal sign to the other side. Now, lots of students will say, oh, this is a negative 2. No, it's not. Okay, this negative right here goes with this 10b. It is a sign for the 10b. This 2 is a positive 2. Okay, so if that 2 is a positive 2, that means that I need to do an inverse, which will make that a negative. So I'm subtracting 2 from both sides. I'm subtracting 2 from both sides because that's the only way that that 2 right there will cancel to give me 0. So at this point, what I'm going to do is just bring down my negative 10b, bring down my equal sign, and then evaluate here. 12 minus 2, and that is going to give us 10. Okay, so what we have now is a regular one-step equation. Negative 10b equals 10. All right, so we are ready to solve for b at this moment. So the only way we do that is to, you got it, divide by negative 10. Okay, because our goal is to go ahead and get that to cancel. So I need just b by itself. Okay, so I'm not going to divide by positive 10 because that's going to give me a negative b. I want a positive b. I want this to be b by itself, that 1b. All right, so we divide by negative 10. Those negative 10s will cancel to 1. So now I have a 1b right there. And then 10 divided by negative 10 is going to give us negative 1. So b is going to be equal to negative 1. And you can go back and check this solution just like we did in the other problem. So you can make sure it actually works. So you can go back and plug in negative 1 for the b, and you'll see that you're going to have equality on both sides. Okay? All right, one more example. One more example. All right, 9y minus 27 is equal to negative 2y plus 6. All right, so first things first, we look for like terms. We got any like terms here? Nah. Any like terms here? No. So decide which side you want your variable to be on. You choose which side you want your variable to be on. I am going to move my variables to the left-hand side. Okay, so I'm going to take this negative 2y and I'm going to move it across the equal sign over here with this positive 9y. So this is a negative 2y. The only way that I'm going to get that negative 2y across this equal sign is to do an inverse operation. So I need to add 2y to both sides. Okay, you can see here what's going to happen. This negative 2y and positive 2y, they cancel. That is why we need that inverse operation. So now I am going to go ahead and continue in my problem. So I have a 9y. Uh-oh, sorry about that. All right, I have 9y plus 2y. That's going to give me 11y minus 27 is equal to 6. Okay, so now we have a regular two-step equation. So we have moved the variables to one side. Now we have a regular two-step equation. This is something that you're familiar with already. Okay, so now since I have my 11y here, I have my variables on one side, this negative 27 needs to come over here across the equal sign to this positive 6. The only way that happens is for us to use an inverse operation. So what do we need to do? We need to add 27 to both sides. Okay? So negative 27 and a positive 27, look, they cancel out. So what you have is 11y is equal to 33. 6 plus 27 is 33. At that moment, what do? It's a one-step equation. We divide by 11 using our inverse operations. So what we have here now is y is equal to 3. Okay, 33 divided by 11 is 3. So again, you can always go back and check your work, plug it back in to make sure it actually works for that specific problem. Now, all of the problems that we've done so far have been integer solutions. Sometimes you have solutions that will be fractions. That's not a deal breaker at all. Sometimes you might have some no solutions or some infinitely many solutions as well. I'm going to do a video of that as well. So hopefully this kind of helps you get your feet wet with solving equations with variables on both sides. If you have any questions or comments, leave them in the comment sections, and don't forget to subscribe to my channel. If you have any other questions, you are welcome to email me at mathvibestutoring@gmail.com. Have a great day.